So I gave you a PDF or a JPEG on your classroom kind of as an assignment. I am not going to check it. It might be a nice idea for you to print it out and fill these in so that way you're learning the stuff as you go. This section is on rational exponents. It typically takes me 1 to 2 days in school to do this, and I don't anticipate it taking much more than that. When you're talking about numbers being raised to powers, a lot of this you can plug into the calculator. However, it's very helpful to understand kind of the theories behind it. So for any real number b and any positive integer n, b to the 1 over n is the same thing as the nth root of b, except when b is less than 0 and n is even. Then we're getting into imaginary numbers and things like that. Some of you already knew that. In other words, this right here was one of the questions on a quiz, but it wasn't written like that. Not a quiz, a homework assignment. It was written like this. And I think it was Emma. I think that, I don't think they went to this step. I'm saying they because there's 2 Emmas. Something like this, which equals this, which equals that. So some people already knew kind of this, were a little familiar with fractional exponents and radicals and things like that. Anyway, I digress. You should be able to evaluate these things. Yes, you can plug them into the calculator, of course. If you were plugging this in, you'd probably plug it in with the little caret button or the x to the y. Basically, it's 27 to the 1/3. Means the same thing as this, which is just 3. So you can see my little directions below say write in simplest radical form or evaluate. We evaluated that. We got one answer. For this problem, 54 to the 1/2, if you plug that into your calculator, you will get a decimal. So important to know that it equals that, which is the same thing as radical 9, radical 6, which hopefully you know is that. So we are able to write variables, obviously, with rational exponents as well. And you should be able to change their forms. So 7 to the 1/2 is equal to radical z. A to the 1/9 is equal to the 9th root of a. And 2m to the 1/4 is equal to the 4th root of 2m. That's all. Writing it in exponential form going in the opposite direction. This is u to the 1/3. And this is p to the 1/2. You know it's a half because that's a square root. We don't write that number 2. So you can see down at the bottom I have 2 evaluating examples. This is just asking you what the square root of 144 is. And this one's asking you what the cube root of, well, that negative can go a bunch of different ways. You can think of it this way. So that's like this. So we get 1/4. Going to the side. So the FAR stands for all real non-zero numbers b and any integers x and y with y is greater than 1. B, sorry, I got distracted there. It's equal to the y-th root of b to the x, which is also equal to the y-th root of b all to the x. It's handy to know that these 2 things are the same thing. Sometimes it's helpful to write it like this. Sometimes it's helpful to write it like that. It just kind of depends on what the problem is. So the next one is we have x to the 3/4, which is the 4th root of x cubed, or the 4th root of x all cubed. Just so you know different ways to write these. Here at the bottom I have 6 examples. I'm asking you to simplify all these. Technically this is evaluate because you can see there's no variables, but the directions I wrote on notes from last year were simplify, so I'll just kind of leave it like that. A to the 3/4 times a to the 1/2. You can switch these to radical form, but it's not going to do you any good. So you need to think about what your exponent rules are. When you're multiplying, two like bases, you add the exponents. So this is 3/4 plus 2/4, which is 5/4. Now you wouldn't leave that in improper fraction form simply because you know that that's what it means. And you can't leave a full set of 4a's underneath the radical. So that's another possible answer. Number 2, we have the cube root of b times the square root of b. We can't multiply these two things in this form, so we need to think of them as b to the 1/3 times b to the 1/2, which is b to the 2/6 plus 3/6, which is 5/6. You can leave it in that form if you want, because it's not an improper fraction. You can't simplify. You could write it like this if you want also. They mean the same thing. So either form is totally fine. Number 3, when you're simplifying, remember you have to subtract the exponents. 3/4 is the same thing as 6/8. So when we go to subtract, we get this. You can't leave it like that. That's equal to this. Which, what are you going to do about that? You can't leave that because that's an 1/8 root in the denominator. You can multiply it by n to the 7/8 if you want. Or you can leave it in radical form. And I'm just going to bring you over to my notes from last year. You can see I did it in radical form last year. So I wrote it as 1/8 root of n. So I needed 7 more n's. And that's the answer. These two things are identical. Number 4, if you were to write this out as a radical, it would say cube root of x plus 4, and this would say square root of x minus 6. Its conjugate would be the square root of x plus 6. So likewise, its conjugate is that. So we're going to FOIL the top, x to the 1/3 times x to the 1/2. So that's equal to x to the 5/6 plus 4x to the 1/2. I'm just going to leave it like that for now. Plus 6x to the 1/3 plus 24 all over. This on the bottom will give you a full x. Those will cancel, minus 36. You can't make it much cuter than that. You have the 6th root of x to the 5th. You have 4 radical x. You have 6 cube root of x plus 24. So there's no like radicals there. You can't do anything with that. Number 5, like I said, this is an evaluating one. They do have the same base, so that's very helpful to us. That says 1/3. This says 3/2. If we get common denominators, that's 2/6 plus 9/6, which is 11/6. So that means you actually have this, which means you can take out a full set of 6 12s, and you're left with 12 to the 5th. If you want to do 12 to the 5th, that says 12 to the 5th, not 125. If you want to do 12 to the 5th, go ahead. And number 6, finally, I don't know why this nice easy one is here. X to the 1/4 times x to the 1/6 is the same thing as x to the 3/12 plus x, times x to the 2/12, which is just x to the 5/12. Let me know if you have any questions.